Scala lazy. Yeah, this is Coffee Compiler Club. Here to talk about lazy argument calls and syntax for lazy arguments, and compilers and language runtimes and garbage collection and side effects and every other thing to do with language implementations. They're all being recorded live. You'll be up in YouTube in a couple hours. Everyone's heard it before. Done. So, we have any complaints about Simon sending an invite out? I mean, near as I can tell, this looks like a totally sane guy to go bring on to Coffee Club. Where's it go? It's the WebAssembly linker guy, and it scrolled way up on the chat. No, yes. No complaints, done. Simon, fire. If you haven't done already, fire off.
All right, will do. Thanks.
Yeah.
Well, I wouldn't complain. WebAssembly isn't a real language, because it's assembly language.
All right. I'll let you bring that up after the speaker's done his talk.
Maybe you just mansplain that to our invited guest speaker if he arrives. Why not?
Yeah, we'll discuss it when he's the speaker.
Where's Theodore?
No.
He's. Oh. Gosh.
Can this meeting work without Theodore?
Yeah, where are you, Theodore? He's not on. That's who I was missing. I knew I was staring at, like, we're short somebody. Fine.
So is somebody trying to get the timestamps in the document?
He threw the. Yeah, we should timestamp it here. What is it? 10:05. I don't know. Somebody put it at 5 minutes, right? 0 hour, 05. I did something bad, so Theodore can clean it up if he wants. And then I don't know, people care. We talked about lazy call syntax because we got another something here. Theodore's shown up. Yay. And then Scala has it, so we went and argued back and forth, and
sorry.
Yeah, no problem.
Well, I was thinking about that. I didn't read that whole thread too carefully, but I was thinking, well, another approach is the Lisp approach, which is you write a macro if you want something lazy, and the macro can wrap something in a lambda if you want it to.
We were trying to not do macros. This is Scala and AA, but it could be anybody, Haskell or not. So if you have overloading and you have arguments that are sometimes lazy and sometimes not in the overload, AA and Scala both say that's a typing error. You have to match your arguments. They have to all be lazy or all not be lazy. And then Scala's delaying the lazy or not discovery until he hits typing time. And so he's able to type arguments that are labeled as lazy, even though they're not evaluating in the context where they're at. And I chose not to do that in AA because I have my one pass parser that doesn't want to delay knowing whether something's in a function call or not. So that's a difference. I would need a later pass to go move the argument into a function call, and right now the typing system wants to have it just up front in his face, known as having side effects or not, or whatever it's going to do or not. So you have to know lazy out of the parser. No one else cares. We're done with that topic.
Well, I mean, I think that things should be lazy by default, but that's just my opinion.
Go ask Haskell how it works.
No, just Haskell.
Yeah,
only
Haskell. Just ask Haskell.
No, like I'm not going to do it like Haskell because Haskell, has run into problems. I'm going to do it like R. So the way R works is that if you pass something, then it's lazy. But if you store it in a value, it's strict. So.
All right. Yeah, maybe. I don't know. I'm going to demand that you ask for lazy. It's not the default. So it's weirdness budget. Everything's eager unless asked for lazy. And then lazy is easy to ask for, but you have to ask for it.
Yeah, I'm still researching that weirdness budget. Like, I mean, if you have a good paper or something that explains the weirdness budget.
Somebody posted a long time ago on here just where it came from, but it was just somebody pointing out
It was a blog article, strange budget. I'll find it.
Yeah.
Yeah, it was
Yeah,
all
and I've
about,
read that, and I've concluded that it doesn't have enough sources to be a good source. But
oh, no, I'm not using it as a sourced material. I'm using it as something that seems obvious to me. You'll scare off more programmers if your language looks too weird. So the closer you look like C or like Java, the more you'll not scare people. Here you go. Put it in the doc if you haven't already.
yeah, I'll put it in.
Okay.
Yeah. I have a rebuttal. Is that the word?
Yeah, probably.
Yeah. I have a rebuttal to that. I just have to look it up.
Oh, you have a rebuttal argument. Yes.
Yeah.
Fire away.
Yeah, he wrote
Uh,
Simon, I think, wrote a blog article basically eviscerating the concept of the strangeness budget, right?
Oh yeah. I also linked it so people can make up their mind.
There you go. So
Yeah,
my
and so,
opinion
like-
is, I've already scared Cameron enough away from AA, so I don't need
So,
to.
so I'm not really interested in what Joe random person on the internet writes. So I'm looking for like real sources. So like,
Oh no, but that's totally wrong, Alan, because see, I discount Simon's opinion because I know him, but this other guy, Steve Klabnik or something, like I have no
Yeah.
idea who it is. And he's on the internet, therefore he's a genius.
Yes.
Gotta take his word for it. Am I right? Like,
Yeah, I mean, especially in this, let's call it profession or in this art, we have the luxury that we can exchange opinions without having to check credentials first. So we can have only merit of the arguments decide correctness and not how many titles the person has collected.
you know,
There you
at the
go.
same time, I think bad opinions often don't generate the feedback that they deserve because it's like everyone looks at it and it's like, I really want to say that this is the stupidest fucking thing I've ever seen in my life, but that would be rude. So I'm just going to ignore it. So it's like,
Yeah.
there's a,
Yeah. When I was a
So
younger
it's-
man, I went down that path of telling people I thought their idea was stupid a lot, and that didn't win me any friends.
well, I mean,
Yes,
what I
my-
found so far, as far as real sources, is there's like this interview with Grace Hopper, who like, I forget what she did, but she's famous. So like, she's better
there's an
than.
admiral.
I
And
have
so
a
what-
clue what she did.
Yes. So anyway, so what she was saying was that like there is a language strangeness budget, but you should always try to spend as close to the line as possible. So
Yeah.
uh,
Again, it depends who is your target audience.
well, yeah,
Stranger
but
to
you
some
do
is regular to others.
the government. So in the government, when you try to spend, I mean, it's obviously there's always a plan that has to get approved, and so that's where you can draw the line carefully. But like, I don't know. I mean, in the commercial sector, there's not really a line. It's just you either go out of business or you know,
There's a line there too.
yes.
If you don't spend your strangeness budget, then the next year the boss reduces it.
Reduces it. Yeah.
That
That's the
wouldn't
whole-
be a bad idea. I mean, it's
Oh,
like
that's how
when
government works.
I mean, yeah, but that's not how we have to work. I mean, we can say I'm not spending this, like
Yeah, I
unspent
know.
complexity budget is not meant. It's like I'm not looking to spend it. I'm happy if I get my language features done without spending it, and everything that's left over is burned and never touched again. It's not an
I would-
invitation that people come up and invent weird stuff because, hey, this language is too normal, is too easy to learn. Let's mess.
I would argue that a language becomes weird in his special parts. Take, for example, Scala. The implicits is his special parts, and is where is the weirdness comes in. In most of the language, the special part of the language which expands all its complexity budget is where the language aims to shine, aims to simplify things, aims to fill a niche. That's my
I
opinion.
don't believe that a spending complexity budget is necessarily solving things better than
But you have
languages that haven't spent
examples.
a
Like
complexity
like
budget
C++
there.
and Scala.
Are we are we mixing up between complexity and strangeness? I don't think those are the same.
Oh, that's a good point too.
Fair point.
That's a very good point.
Fair point.
Yeah, it
But
could be
most of the
strangely simple.
most of the things that are complex are strange by default. At first,
C++ has some complexities that I would claim were just complexities that were not necessarily strange.
yeah, I agree. There is such a things, but there are so few places that one can distinguish between the other.
I think the implicits in Scala are clearly strange. I think Haskell's lazy arguments are strange, but not truly complex.
I think I think complexity and strangeness are nevertheless more related than, for instance, familiarity and complexity, for instance, or familiarity and strangeness.
I was supposed to say familiarity and strangeness are the
or do we say strangeness and is basically the opposite of familiarity, because
kind of, yeah.
Yeah, I think so.
Yeah,
And
I think strangeness is the opposite of familiarity.
all right, then I'd argue the thing that matters is keeping the complexity low and not saying, okay, this language has to look like 60 years ago, and then people complain that nothing useful has happened for the last 60 years, and then everybody is surprised about it. I mean,
okay, but the other point is if you make your language low on complexity and just like C, why they have to switch over this new shine thing?
It's interesting, when Java came out, it had very little on the strangeness budget, frankly. Like, it was so
garbage
collection.
collection.
Garbage
collection was
collection
strange.
wasn't strange.
No, it
already
was
existed in
because
small talk.
how it impacted the language usage was not obvious.
True. Yeah, it took years before I realized how valuable it was as part of the design. Yeah, but coming from C++,
picking up the language,
Java,
it didn't scare you.
Yeah, picking up Java from C++ was a 15-minute exercise. It was freaking amazing. So there was nothing strange about it. It was like, okay, they added one operator with an extra shift thing for unsigned. Sure, whatever. Like, everything else was like brain dead simple.
So
it was mostly removal.
Yeah.
We should
Which isn't
define
hard with C++, and C++ is a giant bathtub full of shit.
So they are syntax identical, almost the C and the Java. So there should be something, the syntax complexity, not the complexity of the language.
So that's something you have to deal with in the Lisp world all the time, that people are terrified of the verb being first and using parentheses, slightly more than other languages.
Slightly.
With Clojure, it's a slightly more. With maybe older Lisps, it's a lot more, but you get the same objections regardless. So yeah. I don't know. I think that's pure, unfamiliarity.
It is. Yeah.
It is mostly subjective.
In fact, it's also a simplification once you become familiar with it. So
coded in anger in both a fair amount, and I can get used to the syntax for the Lispy verb first things, but still not my preference.
I guess what I'd argue for is that simple but unfamiliar is better than complicated but familiar.
Unless you want adoption.
Sorry?
Yeah, unless you want adoption, ACC.
Yeah, I mean, who cares? I mean, at which point in history was language popularity related to language quality? So who cares?
Yeah, but you need some adoption, otherwise you have another thing which you don't want called irrelevance.
Yeah, sure, but I don't think the design of the language is related to that. I mean, like there were probably better languages than JavaScript back in the days, but they weren't ready in 7 days. So JavaScript 1, end of story. So
I think JavaScript got some things right. The early version of JavaScript was a very simple, sort of very pure language.
I mean, the first thing it got right is that it existed. I mean,
interconnected
it was
into the browser.
possible. It
Yeah,
was
yeah.
possible even back in the days to have a better language, but that would have maybe taken 10 days or 12 days or 20 days, but they needed it in 7, and so
Right.
the language that was ready
No,
in
it's
7
exactly
won.
the language you would get if
Yeah.
you gave a guy 7 days to build a language from scratch.
Yeah, yeah.
No better, no worse. And in fact, it's impressive he did as well as he did in
I
7
think
days.
so. That's what I'm trying to say. Yeah, I think he did a good
It's
job.
a shitty language. It's a super shitty language, and they should have never built it. But yeah,
No. There's always a business concern too. You don't have an infinite budget, but you need to have some sort of language present to allow people to do more exciting web pages. So you're going to throw some budget, but you're not going to throw infinite budget. And you're not going to wait for Microsoft to come stomp you down. You're in a race with the guy across the street.
and by the way, Microsoft still stomped them down. So
no, but the JavaScript part took off. The strategy is correct. They needed that language. They needed it now. They didn't have budget. That's what they got.
so they can go cash that strategy check in the bank, right? Bill Gates?
Well, the other parts of the strategy are always, trouble as well. If they hadn't done that, I think it'd have been written off in irrelevance longer, even faster. But they got some parts to stick. Fine.
Didn't they just basically die on code quality in the end? Like it was a complex project and it just got too complex and they couldn't evolve it. They had to do a rewrite that took them years. And
Netscape or
Netscape.
Yeah, I think he means Netscape. Yeah, I mean, the challenge that Netscape had is they didn't have revenue because Microsoft choked off their revenue by paying people to take Explorer and paying websites to put bugs in that wouldn't work on Netscape and paying, so it's like, when you're up against an infinite budget of evil, like look at companies that try to compete with Google. It's the same thing.
Yeah, I mean, in the end, Microsoft also lost the arms race of complexity to Google because their own browser engine couldn't keep up anymore with the things Google invented, and so they went down. I think it's very similar to Netscape story, right?
The longer, bigger term play, played out the same way in that way. I did look at the Netscape code, by the way, back in the early days of Hotspot, the very early days before we released even the 1.0 of the C2, whatever. We were invited to look at their code to see if we wanted to pick up their project as a, on-the-fly JIT code generator. And they had issues. So we looked at their code and decided no.
It was pretty shitty.
Yeah. I'm trying to be polite, but no, I was on the edge of there's something here they could make work, but they're a long ways off, and we were already like much further along. So, and everyone else on the team looked at it and said, no, walk away. I don't know if that was a not invented here syndrome or it was really, really bad, but it wasn't close to what I was doing at C2, so we walked. Fine. We got a different topic. Or are we gonna beat on strangeness budget more?
I have a question that's I've been a little bit stumped on, and that's how to test better.
Yeah.
So my problem right now is that I'm basically testing by writing little example programs.
Yeah.
And then compiling them and sort of staring at the output and saying,
I have several technologies I use for compiler testing. For me, one of the big ones is I have this lattice and I have a complicated meat and I want to make sure that it has the right properties. So I do an easy first startup test every time is I just throw a large sample of generated types at the lattice and confirm they have the properties I'm looking for.
Yeah.
And that's a cubic.
I've stolen that technique from you already.
Oh, okay, fine. So then I have a work list algorithm as the core place where work gets done on the typing. That work list algorithm has a flag I can turn on or off that does small step sort of perfect checking in that if you are not on the work list, you better not have any progress to be made. So I can ask every node to make progress and report if you would or would not. So everybody takes a test flag and they return a Boolean on all the optimizations of any kind. And then if I set the test, then you don't do any side effects, you make no changes, you report progress or not. And I'll run that on every node between every step. And if you would make progress, but you're on the work list, that's okay. It's you make progress not on the work list. I missed something.
Yeah.
Hand in hand with
Yes.
that one is progress
Yeah.
blows the monotonicity locally. So there's the set I did up front, but then there's one I do in the small step analysis. Everybody who would make progress, whether you're work list or not, monotonic.
Yeah, that's one that I decided to defer for later, and my way of deferring it is saying I'm willing to pay about 100x penalty in performance for my small initial programs and just basically exponentially check every node. It's really bad, and the work list thing is in place, but it's just not completely correct.
Yeah.
So eventually I'll go back and make it good.
Okay.
But right now I'm just saying, okay, the programs that I'm compiling are all small, and if it takes 5 seconds to compile, it's annoying, but okay.
Right. So I have roughly the same setup going where our programs are all small, and I'm probably faster than what you're doing, but it's not hugely fast. If I throw this flag, it becomes 5 to 10 times slower. But it catches all progress bugs where you're not on the work list, and it catches all monotonicity bugs, and it catches them at the spot where it happened. So the next thing is that work list, I have a counter that I just count 1, 2, 3, 4, 5 every trip through. And when I throw that assert that says you blew it, I have a count. Now I set a breakpoint on the trip before the count, and I hand walk that through, and it does some transformation, and that transformation should also imply somebody else can make progress, and I failed to get the correct neighbors on the work list, or I failed to do the monotonicity right. So I can get back to the buggy spot in one step, basically.
Yeah. So I've got a different approach, but the same thing. I can sort of get back to the same spot, and then I can say resume and do X number of steps and
right. Yeah,
like
I have
that.
the go until this step.
Yeah, my biggest problem is that so I've been working for probably 5 or 6 weeks on this state unzipping thing, and it seems like it's mostly working okay. All of my example programs currently compile correctly, but it's 20 separate peephole rules that sort of work together to do this process. And they interact, and it's really hard to, if one of them goes wrong, it's really hard to tell which one, because it's just that the result, the whole process doesn't work.
Okay.
And so then, I spend a lot of time sort of poking through and figuring out, okay, at which point is it wrong? So I ended up building this invariant checker.
Okay.
And so I can check about, I don't know, 50, 60 invariants on the nodes, like simple ones, like the two-way connections are correct, and node construction is correct and all that. Right. But then other ones, like the type, if I recalculate the type of something, it's the same as the cache type, and then all sorts of stuff like that. And that's found me a few bugs. Okay.
So you said a bunch of things in there that I would restructure how you're doing and maybe make life easier. So if you have a bunch of peephole rules, for me, they fire one at a time off the work list. So it goes to the same, I can stop forward and backwards at some point anywhere in there sort of easily. And the progress checker guy will catch me if I fail to make the right kind of progress. But this doesn't change the fact that after a series of transformations that each individually look correct, I end up with something that's wrong in the end. And where in that sequence did it fail? what was I fucking gonna say here?
So yeah,
There's a way I lost. God damn it! I had the piece
Well,
missing here.
so I'll elaborate a bit and maybe it'll
Yeah.
come back.
Come
So
back around.
so you know, sometimes the problem turns out to be that a rule doesn't quite match the condition correctly.
All right, I got my piece missing here.
Sure.
So, I have to have I want to say a one-step church roster property, which amounts to if I apply these peepholes in any order, I'll end up in the same answer in the end. And that means they have to have some sort of orthogonal, I see it this way, I see it that way, in whatever order I see it, it'll go through. Otherwise, you ran into this property where you applied X before Y and suddenly the transform, you know, X to Z or Y to Z didn't fire and you're left with a broken state in the end. So that one I just do with a workless shuffle, and there are hard points where I know no more work will apply before I do the next kind of work, and I confirm that I've got identical looking behavior out of the work list.
Yeah.
What I heard you just say though, where I have a sequence of transforms that are interlocking, I have to get in my head what that one-step church roster property is supposed to be and confirm that each of the in-between steps are all orthogonal across some cube of whatever order things are going to go through. And where they're not, you'll end up in this broken state where you've lost some variant, and then you usually have to go. That one I know help. I go sort out what my transform's intending to do, and make sure that I believe I can do it piece by piece and get it orthogonal in all directions and end up in the same place.
Yeah. Yeah, I think it's been part of it. It's just been hard to design the transforms so that that's true, and think of the edge cases. So sometimes it's just that a new condition has shown up that I didn't think of.
Right. Yeah.
And you know, that's so there's a couple of parts to this, which is I think why it's been so challenging. Part of it is, you know, making sure that the rules can be applied in any order, that one-step church roster property.
Yeah.
And then another one is just having good examples, right? So sometimes I get tricky examples, it doesn't work, but then it's kind of a large program and I'm not exactly sure what part.
Yeah.
It's hard to figure out how I've generated that example.
Beat the example down.
Yeah.
Till you get a smaller example to feed in.
Yeah.
Like I don't know. I mean, your problem's a little different than mine, but because of sort of the minimalisticness nature of AA, I can generally write every possible example in a small AA code string and you end up with all possible bad combinations as test cases sort of directly.
Yeah, maybe I've been too lazy about trying to build good code examples.
And then I've taken several go rounds of sorting my code examples in increasing levels of complexity. So I now have many hundreds and they're grouped in sets of 20 to 50. So I probably have near 1,000, maybe 500s.
For AA?
For AA, yeah. And they step up stupid shit that goes on. And the other one you mentioned
those
was
examples. Like I was looking at the tests a bit just earlier. I hadn't looked at AA for a while, but I was like, where do you have those examples in the?
Yeah, they're pure code, the pure AA code, and there's the test parse set. So the pure ones just have like the lambda calculus syntax only, and then the test parse has little one-liners, and they have a program, a complete program, and then they have a type from the flow type and a type from the Hindley monotype type, or an error string and an offset where the error should be reported and stuff like that. I mean, let me go pull up.
Oh, I see. Yeah. Oh, these examples are very, very small. They're like generally one.
Yeah, they grow, but they're small. These are intended to, you know, break you straight up.
Yeah. Yeah, I think I'm taking a wrong approach because I've been writing like larger tests, you know, written in Python where there's, you know, sort of large blocks
Right.
of code.
No, I have shit like the very first test, parse the number 1.
Yeah.
It types as a 1 in the flow and types as a 1 in Hemi Milner.
Right.
Right. And then somewhere way down here, I'm doing something stupid like this, where I've got operator precedence. Oh, and I'm calling an operator the hard way instead of using operator syntax to go get it. And I've got, shit like this, which is like, hey, do I parse a bunch of minuses in a row and get it out correct? Or error cases like this, where I'm expecting to report and where I report it. And that's, parse 0, which is, what do we got here? 50, 60 tests. And then I've up to parse 14 or 15. The next guy down, parse 1's a little shorter. He's saying shit like, do assignments, miss parts, unknown references, conditional math with conditions on one arm or the other, left and right, up and down, chained together. 1A needs to be renumbered, but that's all and or. So it's lazy was added. And so on and so forth.
Yeah.
Yeah, these are all targeted because I did something like I started with
And
20 lines of, hey, let's do a hash map in AA, and promptly had bugs. So I said, what's the smallest test that comes up with that bug? And so I would go do it, followed by, there's another bug, and here's another bug. And then I was like, wait a second.
And you haven't started on the peephole rules stuff, right? You've been mostly focused on
Then
typing.
peephole rules are also the typing rules. I am incrementally, character by character, typing the program as I parse and peephole optimizing it as I parse. Those peepholes are part of the type analysis ultimately. So there's another set of peepholes that would be for optimization only, but things that you do stupid, crappy shit, I'll just clean out in the parser, and it won't matter on the typing, other than I have shrunk my program text that I'm actually typing on.
Right. Okay.
So as I parse, I build an incrementally correct, but very conservative type for the program. And as the parse proceeds, the type gets gradually stronger until I get as best as I can do with a bottom-up typing analysis, and I'm done parsing program text. Then I do a top-down typing analysis. It's called combo. It's in a different file. That one is the ultimate complete type for the program. Using that type, I clean up a bunch of shit, which typically turns into I propagate error messages more politely and clean up the types such that the error messages reported are nicer. But it doesn't. After combo, I add no new errors. If you pass combo, you're typed. And I now have a program semantics I can execute. So it goes parse, which incrementally peepholes as it runs, and that includes type analysis as it goes, followed by combo, which is actually the real type analysis in the end, because that's the one that does the final yes or no.
Yeah. Okay. Interesting. Yeah. I've been only looking at bits and pieces and not at the whole structure of AA.
Yeah. Well, there you go. I can pull up the parser. The parser himself is like one big file. There's a bunch of support files. He's one big file, but he's not that big. And the syntax is really simple. It's a one character look ahead kind of thing. He produces nodes. Every node he produces, he calls the people rules. The people rules do what we've talked about before. All the stupid junk gets cleaned out first. The dead code goes away. The things that strictly reduce happen right away, and the graph shrinks. So when I get out of the parser, I typically have a fairly minimalistic graph that's pretty easy to read and sort of obviously follows the program structure of the program text that came in. But like operators go through this very complicated thing where they look at the type of left-hand side, and then they do a lookup, and then they on a field lookup using the operator name. And if that fails on the local guide, then they look in the class for the operator, and then they do an overload lookup. And then they do a function call based on that. And so all that typically folds away out of the parser because you're not doing anything bizarre there. So he just wraps it up. But the parser injects the whole shebang. And then promptly the peepholes wipe it out. I guess the final step is that the primitive makes a function call, which then inlines as a one-line primitive node for doing, primitive integer add or primitive float add or whatever.
Yeah. Yeah, I think I made some decisions that I wouldn't do quite the same if I was starting over.
There you go.
Yeah, but the biggest thing that's so the combination of wiring up all my function calls, like with the arguments passed, sort of connected into the call sites, has been a bit complex. It's worked. It does work, but and I think I'm going to get good inlining information from it. Now that it's all working, I don't think I'm going to get rid of it unless it starts giving me huge problems in the future. But it means that, usually the problems that I've been having with my my peephole rules end up being around state chains unfolding through function calls. And then because you have this sort of squeeze with a call return, and then you might have multiple call returns for any given function, and they're all sort of wired and coming up, and you end up with this many-to-many relationship.
Okay. So
in fact, you have many-to-many relationships all to deal with, and they all have to come out correctly. And so, and then
I cleaned that piece up, and I had to do special debugging hacks for that stuff too. So the first thing I did was calls only have one return. And if you have multiple returns in your call body, textually, I'll funnel them down to one return. Yeah. So the optimizer might do a lot of different tail returns out of each possible return, but the typing system doesn't care. And so I just funnel them down to one return.
Yeah. My state chains are treated as returns as well. So then call return, like the call return has a return value, but then it might have 15 state chains that are also passing through it.
Okay. So
and then
okay, I'm doing typing, you're doing an optimization. Yeah, so for me, the call has a pinch point. He returns a tuple of values, and everyone has to peek through the tuple correctly. The tuple contains, for me right now, one memory type, one state type, control, I got here or not, state type, and a normal return value. If I was to explode my memory into multiple states, then I would still funnel them to the one return, have the epilogue point. When I do a call in the main body of something and not a function, I'm talking about the call, because I actually do two nodes. I do a call and a call epilogue, call prologue, call epilogue. And the epilogue guy takes the returns from all possible targets you might have called. They're all returning to this one call site. And he explodes out the state pieces that you're talking about. I have one.
Yeah.
C2 would have many as well.
So I start with one, and then I try and unzip it into all of the actual states. And so I consider my compiled result valid. The one state thing that I call it, I just call it all state.
Yeah.
And
mine's all memory.
Yeah. So I have this all state, and before I return, everything merges into it.
Yeah.
And anytime I request an all state, it gathers up everything, merges it, and then it gives me the all state, and then I branch out from that again.
Right.
But my goal was that to get rid of that by the end of compilation, because otherwise you're sort of, for code motion, you're locking everything down, because
separate things. You're not locking anything down any more than they're going to be locked down anyhow, because they're blocked behind the memory state.
But the thing is that if I've got like a memory state of one address and I do something, and then a memory state on another address, they shouldn't interfere with each other. But when they're merged into this all state,
I'm sorry. Yes, the all state.
So then I split them apart into separate memory states, and then they're free from each other.
Yeah, you need to keep splitting. I'm sorry, I heard the other way around. Yeah, what C2 does, and I haven't done yet in the AA, is lazily grows the widening of all state using peepholes that are canonicalizing. They simply say, if I have an opportunity or cost justification, I will move a split upward, so more program gets split going up and down as well. So I'll move the splits so they cover more area, but it's always locally profit driven. I'm not doing it in bulk.
Oh, okay. Yeah. Yeah, it didn't occur to me to try that, but I did find that I had to do that splitting from one end to the other. So I ended up putting a flag on the nodes saying that they're clean for splitting. And
Yeah.
so then the rules check if it's clean, and then if it is, then I can split. And so I basically start from the halt node and I mark the first all state clean, and I start splitting. And then as it is split out, it moves up, like basically it progresses, and the all state beside halt, if it's clean, ends up getting peopled away. And so you end up with it sort of evaporating from back to front. But at first I had the rules without that, and I ended up with many parallel versions of the same state chains.
Oh, that would be bad. You have to be careful there.
Yeah. So, and the reason was that you could unzip something in one place, but then unzip something somewhere else, and it would just sort of jump over it. You had to rely on that sort of all state chain being continuous.
Right. So what I just heard was that you didn't have a local people semantics. Like C2, AA, I have a memory split, memory join, and I will put them in the appropriate place. Like I decide there's profit, I put them in as a pair that has nothing in the split. But a memory join now has a people rule that lets things come from below the join to above the join, which means they go into the more refined space where each of the different pieces being joined represents a separate unaliased thing. So I have alias classes that are based on, Java-like typing system stuff. And if you're below the join, you're in the all state world. And if you're above the join, you're tagged on one alias class, and you're independent of the parallel join pieces. And same for the split and reverse. And then those two in pieces gradually move apart, splitting as they go, but they're always locally correct. If you stop at any point, the answer is program is correct right then and there. You don't have a problem where I failed to split here and I did split there, and therefore I'm broken. You're always correct step by step.
Yeah, maybe there's a rule there that I missed that would have made this simpler. Yeah, honestly, I've been thinking of at some point coming back and redoing it, and I'm just hoping that I can get to like an alpha quality, sort of everything's working.
Yeah. Okay.
Before having to do that, because I don't want to spend weeks doing this over again.
Yeah. Okay.
But
well, the other option is to turn off all memory splitting until you get an alpha quality done, and then you don't get any load store bypass and code quality suffers, but you get to get code and test everything else, and then you can come. I mean, the whole point of having it be incrementally correct is I can add the mem split, mem join, and have it do nothing else, and nothing else changed, no improvement, but I can see it's correct. And then I can say, okay, I'm not going to let you load, sync unrelated loads into a split region, and they'll now be parallel, and I can reschedule them independently, and and see, that worked. And then unrelated stores can move up, and that's a little more complicated because you have to look at the uses on the stores and blah blah blah. And then now I have loads and stores that are well aliased against everything else, and they touch each other, but there's no other connection. So that now I can optimize load stores and load after store and store after load and store, and all those optimizations kick in really.
Yeah.
I mean, they can apply in an all state world, but they don't happen very much when you split.
That's right. Yeah. So they typically only start, they only start appearing mostly afterwards. Like when I'm in a local function body, I don't merge every time. If I've got some split state and I need that state again, I just use it. But yeah, like normally those things show up later after all the unzipping is done. I have to be like a bit cognizant of just producing an end result that has at least some level of optimization, or I'm afraid that people will look at the project and be like, oh, this is no good. The performance is too bad.
Yeah, I see.
I don't want this. So
right.
Yeah, so it's a bit of a balance. I was also thinking that maybe I should just forget about the all state thing and try and build directly into the fully split state. Although whenever I think that through, it seems very complicated because
Yeah. So
because the problem is that sometimes states appear in a function call, and then you need to know that it exists afterwards. But I don't. It gives me an ordering requirement on my function definitions, which I don't have right now, and it prevents mutual recursion.
Okay, so AA and C2 have different issues here, and I can talk to both the experience, but the AA experience is much more incomplete. For C2, I don't actually have any function calls that I'm optimizing through. If you're a function call and I want to optimize you, I inline you.
Yeah.
Right. Okay. So that one gets away from the split joins in the body, like splitting into a function and then bringing the splits back out because I just inline the function and then I just have.
But does that mean that you never you're really limited in C2 in terms of how you can do code motion in the presence of function calls? Because you can't like move anything that's memory related.
That's correct.
Around any other function call.
Right, that's correct. It is a hard guarantee with C2 or hard issue that optimization's predicated on good inlining. So instead of saying I don't move around code or function calls, I instead said, if there's any hope of having progress, fucking inline.
Yeah.
And I'm much more aggressive about inlining. AA, I'm doing the other thing. I'm doing what you said, and I'm optimizing in and out of function calls. And at this where it stands right now, I've turned off some of those memory things just to get the typing done. But the end result of the day, I'll probably split through small functions in the typing. Now, when I get the optimizer, I like what happened with AA with a C2. I'll stare at it and decide if I want to care. I'll probably do enough optimization to know that a bunch of aliases are untouched in a function. And then the function will know that, he's not ever going to screw with, and I'll do cheap little bypass around it. But I probably won't have outside of the function call cause splits to happen inside a function body. Instead, the function body will decide he's splitting because he has internal uses and he's separating out the different aliases he understands about those internal uses. And then the callers will decide when they look at a function that they have alias information enough to bypass or not. And then the optimizer might just say, okay, inline it so I can get the aliasing sorted out or not, or whatever. That's an optimization call.
Yeah. 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 It's probably a bit simpler. I think I went for a bit too complex of an approach here. But
yeah.
I also think in the end, it might be a bit of a waste of time if I end up inlining everything anyway.
If your programs are all small and they have to be reasonably small to fit on a fixed silicon piece, there's a rule that says if you get all the hot shit inline, maybe you don't care about the cold shit. I don't know.
Yeah, I'll see. There's a fair bit of work that has to happen, and it's a fairly small, tight memory. So my thinking is that I might not be able to inline everything. It's been kind of my assumption.
Yeah. Well, there's outlining too, which, you talk to the small code size guys who do outlining.
Yeah, I haven't even thought about what that would entail.
It's not terrible. It's kind of like value numbering where you hash things with common patterns. You hash to find an initial common pattern, and then you look at opcodes without inputs and hash, and you say, oh, I got 2 billion ads. Well, that didn't help you very much. But then you look at the inputs on the ads and say, I have this structure, and then these guys have some kind of opcode, and there's a pattern where I do X divided by 3 plus 17 or what the hell, and you filter out your hash table, and then you add the common patterns and you hash again, and you get a new larger pattern. It's like a Limple Ziv guy, LZG guys or whatever, LZW guys. You're looking for common patterns on the graph to put into a dictionary. and you keep growing the common patterns in the dictionary until they get big enough, you cross some threshold of excitement, and you say, ooh, I'm going to outline you. And you know, once you finish growing as big as I get, you stop and you go and grab whatever the biggest chunk that makes sense and declare it a function call.
Yeah.
I've never actually implemented it, so I don't know how well it works.
Yeah. It might be something. So I've been in my mind, just keeping in the back of my mind a little bit, how to deal with code size limitation, because I'm not 100% sure what my code size will be when I'm doing the optimization, and
Yeah.
I don't want. So, you know, maybe there's an approach there which says you end up with a program that's too big, and now you start saying, okay, I'm going to start outlining until.
I would also ponder recompiling with a smaller compile threshold, a smaller inlining threshold. So C2 has to watch out because you get iCache blowout if you over inline. You know, it's a little weaker version of what you're talking about, but it's a real strong effect. If you blow your iCache budget, you suffer. So there's a bunch of heuristics that say don't inline now because you're blowing iCache, and the usual one is I have a medium hot method that's already gotten big and I've compiled it. And now I have another medium hot caller that's trying to call this guy. And at some point you say, you know, it's all meh medium to meh medium. Don't bother inlining.
Yeah.
If it's hot and you're small, it's obvious. If it's hot and you're big, it's less obvious, but maybe. If it's, you know, cold and it's small, it's still pretty obvious. And then you get to and it's kind of a meh here and it's a meh there, and you know, code size. So you know, don't do it. And that's part of the.
Yeah. That's
And the thing there is you could just come back around and compile it and then decide it's too big and then go back, compile it again and report. Next time, throw in -XX : compile threshold equals blah, and I'll shrink the code down. You know, restate that. Put in some hints for inlining for code size because you have a small fixed footprint. You just don't work if you just don't fit, and somebody will always squeeze around the edges trying to get you in or not.
Yeah.
So you throw flags in, you know the flags are coming, you know you need a heuristic, pull apart the heuristic and set it aside and say, this is the heuristic that decides inline or not, and everyone's going to call it. I'm going to put my heuristics hacks in there, and that'll include default flags and user flags and yada yada, and it'll get big and complicated over time, but know that it's coming. So just build it now and set it aside and say, this is where the decision is made. It has a lot of parts to it. Don't let the decision spread out throughout the code.
Yeah, that's a good idea. Yeah, I have a plan to eventually, because I'm not doing the full inlining yet. So my plan is to build, you know, a call tree and do some analysis. I also realized that the structure that I have with the wired in call sites seems to give me good information on inlining profitability based on like the call. So I have this like call return object, basically node, which for every call site where it returns, there's another instance of this, and the function wires into all of them. And if I look at all of those and count how many fees there are in there, it should tell me how good this will be when I inline. So if none of them have, like, if there are, I think if there are fees, it means there are different code paths.
You don't have any profile data, right? This is all static heuristics.
It's all static heuristics, but because I don't have a lot of external input, I think I can statically say exactly what most of my loops and stuff
C compilers for years on end.
Pardon me?
So every C compiler on the planet for years on end.
Yeah.
Yeah. I mean, you count loop nesting depth and you count size of function body, however you want to measure it, and decide small function body deep in the loop nest, I'm going to claim inline or not.
Yeah. And I think I can do specialization with this technique. So yeah.
Same way, be inline.
Yeah.
Oh, here's Matt's been busy in the chat. They make it into the doc too. I mean, look, a bunch of links there.
Oh, okay.
Some of them. Oh, outlining. Yeah, there it is. That was a YouTube watch. I'll read it later. Yeah. So Matt, the land of C2, not AAs. I have a lot more flags for doing dynamic compilation management to figure out which compile wrote broken code. So like C2 ran and produced some code. Then the JVM crashes and like we suspect broken code generation. How do you diagnose it? Well, the problem with C2 is it's got dynamic profiling and he generates code and it's different code every time. And how do you know? And then of course, once the code's broken, something subtle breaks down the road later and who's to blame? So I have a bunch of binary search techniques on C2 for turning on and off compiles, and turning on and off inlining of various kinds, and picking things to specifically exclude or include based on a text file that you can edit to say, don't compile this guy. And then they all have like binary search options on them. So you whale away with binary search to come up with the
Are there
dude
tools
who's
to look
at
at a heap
fault.
dump and know what got JITted and what didn't?
Yeah, I have a list of everything that get what got JITted and what didn't. Yeah. And then 10,000 things got JITted. That's a common scenario for a medium large program. Like 1,000 things for fucking getting to main. Okay, it's 100 things to get to main. 1,000 things for a small program because you get endless string and security and class loader jitting things that are crazy. And then, you know, the actual application starts coming in and you get 10,000, and that's, yeah, you're probably not going to get huge amounts of that unless you're a very large guy. But still, out of 10,000, how do you pick one? Well, certain crashes come immediately afterwards. So if you crash somewhere and you suspect code gen and there's the few compiles at the end, you immediately throw them on a don't compile list and try again. And they got something else actually died because it was inline 3 layers deep. Now it's inline 2 layers deep and it still dies, but later you can home in, you can print all got inlines, you can xcomp, which is basically JIT without profile data. But you'll get a hard crash immediately after compiling the guy in question. I don't know, mostly once you sorted out how to do it, you mostly could get there pretty quickly as to what JITted code was the issue. Kind of depended on the nature of the bug. The ones where you failed to correctly print the garbage collection information at a safe point required the garbage collector to hit that safe point, stop you there, and then decide to move the method, the object in question, fail to notice the compiler was using it because the compiler didn't put the right information out. And then when the code picked up and ran again, he grabbed the wrong pointer address and died. Those were a lot harder to run down. So we had more flags for doing those. Like you talked about having every call, a function call can go to many functions. Many function can be received from many calls. The returns have the opposite problem. The return from one function go to many call sites. One call site can get returned out from many functions. I have both C2 and AA had a bunch of flags that diagnosed that. You know, C2, so AA right now at least has a thing called like sane underscore return wiring or whatever. I call it wiring a call to a function call to a body, where the call site wires an edge to the function header and the return of the function wires an edge to the call return point. And I have a special assert just for that. Anytime I do anything around those. So, you know, a common scenario is I've wired you because I don't know who's going to call whom. So I make a conservative assumption at some point you got wired in. Later, I discover that that can never happen. And I want to remove that edge. And so the optimizer is busy saying this control flow path is dead. So I'm going to, you know, yank it off of here. Well, I have to yank the matching yank at the other side. And so somewhere along the way, I have a special assert just for that set because that one was a nasty, happened rare enough. When it happened, it was difficult to diagnose because then things are in the middle of dying because you've decided that edge can happen because there's no control flow there. So all the code related to that edge is going to go away and you get a lot of fold up happening. after the collapse has happened, this is a whole Churchwasser one-step property. After the collapse has happened and you're busy cleaning up the mess, and it's getting back down to something sensible looking, you've made a mistake earlier. Now you have trash, and you immediately deleted 90% of what you would declare was the mistake. So those guys got special love early on for asserts.
Do you go through any states where if you stopped after a specific peephole was done, your program would, it may be sort of syntactically correct, but you couldn't actually compile it to the end, like you couldn't actually produce code on?
I go through states where I have, like, I had to go sort out that I always have a real program semantics for every graph at the end of any peephole. There's never a time when I don't have a semantics. After, in the middle of the peephole, shit hits the fan. After the peephole, you always have semantics. Now, having said that, some of the semantics are sort of bizarre or junky. Like, I have code that has no uses, so it's dead. And I could evaluate it. I could compute an answer, but no one's going to use that answer, so I want to throw it away. I also have control flow paths where I know I can't take it. So, you know, there's an impossibility there. There's like, if 0, then on the true side never can happen, but I have a cast that says cast the 0 to not 0. So the cast has special hook to say, if you cast a 0 to a not 0, I know you must be dead, but you just haven't got around to cleaning it out yet. So I'll produce a value which is monotonically correct at this point in time, but is not actually sensible. And it is specifically the 0 not 0 value.
Mm-hmm.
0 is not a 0 value. And it shows up in the lattice as an element point in the lattice. And I was like, well, who the hell, well, I have to have this. I couldn't make a lattice without the point. But it turns out that, in fact, I can get to that point.
It's a very specific numbering system.
Yes. Exactly. So there are places where in prior life, like I tried C2 where I had a version where I had to complete some set of peepholes wholly before I had a valid program again. And that turned out in practice to be too difficult to diagnose failures if you screwed something else up.
Yeah.
So I went back around to, I have a semantics at every point after each peephole. Some of the semantics are ugly, but they're valid program semantics.
Yeah. I end up with some of that too, like when I'm doing the unzipping, that sometimes a function has a state that it is passed in as an argument and then not returned, and that state just sort of goes straight to the halt, like directly. It's sort of like,
I see.
Like,
yeah.
But it's like kind of, well, it could make sense that, okay, that's just, that state chain is never used again, so I can just sort of throw it away. But it can mean that meanwhile some operations have to be done even though they're not really tied to any return. It's kind of weird.
Yeah, I specifically said no to those in AA. Like I tried some of that at C2 and I backed away from it.
Yeah.
So in C2, if you have like a bailout to the interpreter, that's a known program point that goes to the halt guy.
Yeah.
But I don't have an inside of a function going to the halt or returning. For AA, I decided I'm not going to do that. You're not going to halt from inside of a function. You're going to go to the return and unwind the thread all the way out to halt.
Yeah.
And that,
So halt is a throw.
Yeah, basically, you know, system.exit, uncaught exception. Like I will surely have some syntax in AA that says, and the programmer doesn't know what he wants to do here, but he knows there's something you could get here and doesn't know what to do. So it's ... as a halt and catch fire, stop in the debugger, and then look and see what should I do here? Whatever, figure out how I get here in the first place, right? So there's a shortcut, and that will, you know, semantically, it'll be as if you returned all the way out to the program exit.
Yeah. I guess unlike a CPU, our thing actually does have a halt instruction, which just literally stops everything. As well.
Okay.
So
how do you restart it?
That's separate from the end of the program.
How do you restart it?
You have to send it a debug command.
Okay.
Basically give it a kick externally.
External kick, yeah, it's external interrupt, yeah. Well, so you could treat that as a function call that took all state, returned all state, and just internal to the function call it blocked, like a blocking IO operation until you restart.
Yeah, and I'm gonna make use of it because it's something very close to a breakpoint in hardware where I can just really stop things immediately when I want. So it's kind of nice.
One of the fun things that happened at Azul, we had this hardware transactional memory, which would, if you unwound the transaction, you lost the transaction state because that was the point of hardware transactional memory. Now you had to go debug this. So somewhere in the middle of working a transaction, somebody tripped something that aborted the transaction. By the time you got control back from the hardware, all state was reset to be before the transaction. You had no cookies left behind. You could not have a cookie left behind that told you how and why you aborted.
That's very helpful.
Oh, God. We eventually talked the hardware guys into letting us set a register that survived that was, it took an int as a special custom register. It bypassed this whole unwind thing. You could get a cookie back that way.
Yeah. It would make things hard to debug.
Yeah. So instead, we also ended up with like a lot of counters. We've tried this transaction 4 and 5 times, 10 times, 100 times. It's not working. How about we just lock and do a Java lock instead and do it the old-fashioned hard way? And that happened. And then eventually you diagnose, oh, you got false sharing between these two unrelated looking things, and they're both on the same line. One's getting written to by nothing to do with nothing, and the other guy is what's trying to transact through, but false sharing kicks the line out of the L1 cache, so transaction aborts. Fine.
Yeah.
I heard a similar complaint from the people using the quantum computers that if you get your setup slightly wrong, what you get back is actually pure randomness.
Oh, pure random.
Like the quantum computer, if it completes its surface minimization, then you get an answer out. And if it has got a bug in there somewhere, it just wanders around the state space.
And gives you an interesting
hardware quality.
Like I at least got a no back. I knew that I failed the transaction, but all I got was a no.
Quantum uncertainty.
Yeah. Yes, and the usefulness of being able to debug.
Change of topics, maybe.
Yeah. Somebody else has to come up with
questions?
something. I do have one speaker for sure. One speaker is a strong maybe. One speaker is a weak maybe coming up. So we might get some guest speakers here past Gilad. And Gilad was fun. I could do that again.
Yeah, did you tell people that they can just join us even if they don't want to give a talk, or that they can also return without a talk if they have given a talk or something?
Okay, yeah, I think they know that, but I could be explicit. Like both Jan and Heinz are on the list. They get the weekly invites. They just don't show up very often.
Ah, nice.
And they both have interesting things to say, so it'd be good to have them have a dedicated slot. Yeah, I mean that's the standard way I do the discussion, the invites. I'm hoping it's obvious, so you can just show up and talk if you want. We have our steady set, and we get occasional folks from outside coming in. It is what it is. All right. What else, or is it break for done already? We don't have to go 3 hours.
I can do a short update on my core struggles lately.
Oh yeah, sure. And I can do a core AA short update on AA, and it's all Alan's fault.
If you want, you can share the Google Docs. I pasted a small snippet below links.
As soon as I find the you just want me to share it, which I can totally do.
Yeah, just do it.
Fine.
Otherwise, I have notifications.
Bike shedding.
Yeah, so the ultimate bike shedding. I mean, I didn't get anything else done. I'm still fighting with the semicolon in front. So bike shedding on something else it is now. Well, yeah, collection filtering. So the baseline where I'm coming from is that many languages have this notion of filter that takes a predicate, and everybody has just to remember whether you're
Filtering out,
filter out elements or keep the elements you're
Yes, I
filtering.
love your retain and reject. I think that's
So
yeah.
I came up with retain and reject, and I managed to find a set of operations around them. So I have, I think, 4 now. Retain first, which just takes the first 5 elements, for instance. Retain index, which is like retain, but evaluates the index, so you don't have a predicate on the value, but at the index. And retain while, which basically says, okay, take everything from the start until the predicate goes false. And I have the exact same set for reject, and that makes me rather happy because it feels really consistent. The words have the same length, they have the same prefix, and now the only little question remaining is, okay, what I'm doing with those operations where I want to keep both those filtered out and those filtered in. And yeah, I mean, there is stuff like split or partition, but I haven't really considered that yet. So I'm pretty happy. I'm already updating the standard library to have these functions with these semantics, and at least that's going well. And apart from that, I'm reading up on how dynamic linking works, and it's interesting because there is, I think, not that much information that's specifying things, and
When you say
just
dynamic
a
linking,
lot
you mean
of
loading DLLs at runtime, or
yeah, depends on not runtime. It's like the things you refer to in your elf file, for instance.
Yeah.
And it seems like most of the documentation is basically, yeah, I looked into it and it appears to be behaving this way, and so it's more or less documenting behavior and not the reasoning behind it, and that's a bit frustrating. And yeah, the goal is to figure out which things as a language or runtime implementer can be moved to link time, and how can I make the linker do more work than the traditional linker for C, or like the traditional linker for ELF artifacts usually produced from C code. Let's say it this way. Otherwise, there's confusion with like static linking, and it's not what I want. Yeah, so that's the update from me. And I hope if we can invite someone from the WebAssembly crowd, that I can learn a few things there, because they pretty much have the same issues that I have. So let's see.
Yeah, I don't know. I mean, we were chatting on the Discord about this linking stuff, and I still don't understand what you actually want. So I don't know.
I threw in a short code example from AA if you care to. Actually, I'm sorry. I'm changing topics and I shouldn't do that yet.
Yeah. Well, I mean, I don't know. I mean, it's. I'm not. I think that was the end of the discussion.
Okay. Yeah.
So I had a
wrote
question
linker
back on the way you were
30-40 years
thinking
ago,
about
but
filters.
times.
So
Sorry?
your description of filters seemed to be only about filtering stuff out. It would be hard to write a filter that says group by 2s or group by 3s.
Wouldn't call it filter. I mean, no,
Yeah.
I wouldn't call it reject or retain. Yeah, that would be.
Yeah.
Apply
Like,
map.
what if I want to read 3 elements and return a third as many elements as I get? Or I want to write flatten, where I'm reading things, unpacking them, and giving back more elements than I took in.
Yeah, Cliff, if you want to click on that link I posted, there's the whole set of thingies.
Convention
exactly. So if you see there, I have like this subsection on filters where I bike shedded a lot previously, and if you scroll up and scroll down, you see that filtering is not the only section. So I have map and flat map, which I think is at least related to flatten, and I think all the group by stuff you mentioned is somewhere below, but I really haven't thought about it that much yet, because currently all the implementation is implemented directly on collections, on lists and arrays, which is, as we know from Scala, incredibly inefficient. So before I basically finalize anything of that, I need to port it to some streaming type.
Yeah, so the 2 things that I tend to recommend there is to think about a function that can yield. Like, can I have something where I keep handing it elements and it's yielding elements? And if it wants to split, sure, that's easy. I just call yields twice before the function returns. And if I wanted to join things, I just don't yield and keep taking more things off of the queue, which tends to work in Python because Python has generators and iterators and yields. And the other thing I would look at was closures transducers, which is a similar, how do I maintain some state as I'm going across this list? Because it always struck me as weird that it was relatively easy to filter things, but if I wanted to return a slightly longer list, I couldn't be like, take element, take element, take element. Oh, this thing probably should have been 3 things, so I'm going to give you 3 more elements. And it's like, oh, but you can't do that in the ways that most of these sort of functional stream processing things work. It is often difficult to turn 1 event into 3.
Yeah.
Whereas it's often pretty easy to turn 3 events into 1.
So the function that it has different names in different places. In Clojure, it's called mapcat, but basically it's you know, and you can use that for filtering because it basically it concatenates together the results of every call to map. That's a map where you return a collection and then all the results are concatenated.
So basically flat map, and if you want to filter things out, you just return an empty list.
Yeah, you return an empty list, and if you
most of the
3 things, then you return a list with 3.
Most of the things are masked in the signature. If you filter, you take something and returns the sequence of something or the same thing. And most of the operations are masked inside the signature. They don't know explicitly what will you do.
I don't understand what you mean.
If let's say if you filter, the filter takes the element of the signature and returns another collection with the same signature. It could be slightly larger, it could be smaller, but it's masked inside the signature. That's why I didn't get.
Flat map or mapcat does the same, right? It's still returning the same type of.
Yeah, I think Derek just showed another approach to implement filters without needing an explicit filter function. But I guess Clojure just also has a filter function.
When your map many here specifically returns 0 to n elements for each element, and then
it's what we traditionally call flat map. I'm partially happy with the name, but there is a lot of bike shedding to be done.
Okay, fine.
I would highly recommend one talk if you haven't seen it yet by Barry. I posted the link in the docs. He compares implementation of filter in multiple different languages like Rust, D, and C++, and every single language has some problems. And you will have to decide which problems you like the least, which problems you like the most. But whichever you choose, you will have problems with filter. So I highly recommend this talk to see the trade-offs.
Which one is this?
I posted the link in Google Docs. It's the talk by Barry. It's called Iterators and Ranges, comparing C++ to D, Rust, and others. And filter is one of the examples that is the running example used in the talk.
Cool.
It's highly recommended. I have listening compiles on that forum across multiple languages, so it's very good talk.
This reminds me of I think also a C++ talk where the focus wasn't so much on implementation but only on the naming, and I can't find that talk anymore, but maybe if I dig into this one, there are some hints.
Can't find the name of the talk on how to name things. That's
exactly. And this purple, I mean everything every search term I use for it seems to be so misleading to search engines that I get very generic results, and it's super
just
unfair.
ask ChatGPT. If it doesn't exist, it'll just make one up for you.
I remember two talks that were about naming in C++. The one is by Katie Gregory, so you can search for C++ Katie Gregory. The other one was by Conan Hoekstra, and he is usually going through like 10, 12 different programming languages and looking at the names of algorithms in those, so it could be that one.
Yeah, can you post the
yes,
link? Because you're very loud and you're very I'm not sure it's over like
full mic. It's a full microphone.
Audio is clipping a lot, so
Wow, that's a ton of reading. All right.
Oh, and by the way, Matt, thanks for the link to linking and loading. That's I didn't know that yet, and that appears to be really interesting.
Oh yeah, sure. And he has an entire series of what should be kept in linking and what are the things that are just historical. So I think that's actually right on track here.
Thanks a lot. I think I'll read that immediately.
Sure.
I've gone through multiple cycles of thinking I knew what the operating system did when I loaded something before calling main, and have decided I don't. You would think there wouldn't be that many steps. Copy the binary into memory, jump to the entry point.
Yeah, well, if you don't do relocation, if you don't do shared libraries, then everything is easy.
Yeah.
I'm pretty sure at this point you could teach a semester-long class on ELF.
I'll stop reading it now. Yeah, a long time ago in a galaxy far, far away, I redid the linker for, gosh, I want to say it was an early version of GCC for use inside Motorola. That was my introduction to all the crap that goes on inside linkers.
Does anyone have a guide for what to read if I want the operating system to not load the entire binary into memory? And say, here's this section in my ELF file, but that's just there for like debug symbols or whatever, and you don't need to actually pull it into memory.
Oh, you can look at the ELF spec.
I mean, does it have to be? Do those bytes have to exist in the same file? Because otherwise, put it next to the shared library or something. Yeah. Maybe. But yes, I also had this question, so if you have the answer, please let me know.
Yeah, the particular piece of horrible I was trying to figure out was if I wanted to have a binary that kept a database with it, so that my binary was essentially all of the binary code with a SQLite database appended to the end. and my binary would come up and then it would open itself as a SQLite database, and I could mutate the stuff that was on disk and close. And now if I moved it, I could just move the one binary around and it would have both the application and the data in one.
You wanted to rewrite the executable binary.
Right.
I know
but I don't
Mac
want to rewrite
OS.
the parts of the executable binary that get executed. I just want to rewrite the SQL database that's hanging off the end.
I know Mac OS has layers in the file system, and you can actually have multiple layers of data in a file.
Oh.
This is a good way
So
of
two different data streams in the same
storing
file.
viruses
with each
on
other.
a system. I'm not sure if it's useful for anything else.
I mean, you
OS is just say no to you when you try to go rewrite the binary.
I mean, you could put the SQLite database inside a zip file, append a zip file to your ELF file, and then regularly load the ELF file as a zip file.
How are you
No,
going
but he had to write it back. The database wants to write it back.
Oh, that's more complicated, I guess.
Sounds very virusy. I hate to say this, but I was involved with probably one of the first viruses ever on an Apple II, where the bootloader had a 1 byte left over that we could put a count of the number of times that we found the virus on the boot and added 1 and stored it back out on the boot. You could tell you had a virus disk because it would have 1 extra write after it. Stick the disk in and have it, start reading the disk and boot up and come up. It would scribble the boot 1 more time to set the bit. And that was our, self-modifying on disk binary. And then not me, the other guy took this disk off to an Apple game sharing hub and passed it out. And it very quickly overflowed our 1 byte. We had no idea how far and how fast it went, but it was clearly, random numbers of overflows on that.
Nice.
And that's why we need saturating ints.
Yeah, exactly. It didn't have enough instruction space because you had to lift from the boot sector, which was already pretty full. So we optimized the boot sector. My part here was optimizing the code on the boot sector to shrink it down a few bytes. So we had a few bytes left over to go do other things. I mean, it didn't do anything else on the whole virus. It's just our variant. What the hell? I must have been early college, 19 or 20 when I did this.
The trick to doing things like that is to do it before the Computer Fraud and Abuse Act got passed.
Yeah, exactly. Fine. I'm afraid I used computers in many interesting ways that are these days would be frowned upon. But back then it was just like, yeah, whatever. You were doing what you're doing. It was all good. Broke the security on an IBM mainframe because I accidentally didn't understand how to not break it.
Well, that wasn't much of a security then.
Yeah, no, it wasn't much of a security then. But way before any kind of, people kind of sort of understood they wanted security, but had no theory behind it, and certainly no crypto or anything like that. So security by obscurity. And I read
IBM mainframes login was not case sensitive, but accounting for computer time was case sensitive. So if you just put a random capital somewhere in your name, it would not take. You could have as much times the amount of compute time as you had been allocated by just doing it. So you're like, capitalize the first letter. Oh, out of compute time, capitalize the second letter. Out of compute time again, capitalize the third letter.
Interesting. I had something kind of similar. I changed my name, my username, and they ran it through accounting as a separate step from when it got loaded in. So I went from, Cliff Click, CS204 or whatever to the Fearsome Jabberwocky, which, defeated all.
Objectively a better name.
Yeah. And then I got free computer time. And then after that, I started optimizing how fast can I get through the 2-hour wait queue by changing the JCL, which turned out to be the security hole, which I cranked up my JCL permissions so where it would stop somebody else's job mid-print, my job would print out, and then it would go again. When the operators who ripped the paper off the machine knew my face, but not my name. So they were all confused because I kept appearing in the middle of somebody else's job. And the other people in the room were starting to get suspicious because I had turnaround time in seconds and not hours. And the last one I did, I had the security, the permissions of the priority set to max. This apparently ejected the task scheduler, ran my job, and then the machine never ran again until they rebooted the mainframe. So I took my second to last one, because my last one never came out because the print scheduler and everything else just didn't go. And I walked out the door and turned in my second to last, project, and printout was done. So there you go.
Leave the task scheduler alone.
It turned out that they had 16 priority levels, and you could pick whichever one your job ran at, and the task scheduler ran at priority 15, and students ran at 0, and the print was at 14 or something. And once I figured that out, I said, well, fuck it, just go to 15. And it went 3 or 4 times through fine, but then it finally ejected the task scheduler, and I didn't get nothing. Nobody got nothing out for a while until they rebooted, and then they were looking for the fearsome Jabberwocky, and I was done with that class and out of there.
Okay, next
Sorry.
topic.
Stupid pet tricks from when you were 20.
Still waiting for my printout.
Yes. Yeah.
That's why my question every time you show closures in AA is how secure they are.
There you go. Well, I intend for them to be closures, so that's supposed to be reasonably secure. Aaron caught me out with maybe do a test case. We were talking about polymorphic nilability in function calls, which I could pull that example up too. But anyhow, I missed a bug on my nil checking that I had to go sort out, and I blame Alan for that, not Aaron, Alan. That turned out to be fun. It went on the chat some time ago, but maybe it doesn't matter. It's just like,
what was the problem?
The actual problem, I was trying to look for the test case. It makes it easier to understand what the problem is. And I've lost my test case. I don't know where it went to. All right, fine. The problem was, where is the Google Docs? Get my context loaded here. Oh yeah, the problem was that I'm doing nilable, Hindley-Milner nilability, polymorphic nilability, which is not a common thing. It kind of sounds like it ought to be, but it's not. Like nil checking, like you get out of Kotlin or something, but it's a little more powerful in Hindley-Milner. And I have a test case which shows you the kinds of shit you can do with it. And if I can find it, which I can't, so I'll talk it out here. So the idea here is that out of like a map call, it takes a function, and a collection, and the Hindley-Milner can verify that the collection is only not nil elements, and the function then therefore does not need to nil check the elements or not. So a map where I have a collection being passed in, and the collection has some nil elements, ABC and null and BF, and the function involved is string length, for instance, right? And this will give me, type error, string may be nil, right? Something like that. Or if it's known that has no nils, you're okay.
Do you want to share your screen? I just noticed.
Oh, I'm sorry. I'm stuck on the
You're
Google
on screen
Docs.
share.
Let me share the Google Docs. Yeah. I'm busy typing away. Not paying any attention. Here's so here's a collection that may or may not have nils in it. You can call them options if you like or something. And then the one guy, the first one throws an error because there might be a nil in the collection. And the second guy says it's okay because there are no nils in the collection. And the third guy is okay because even though the collection has nils, the function tests for nil and doesn't do an illegal nilable thing. So basically, map will track nilability through both the collection. So map will take a collection. So the type of map is has two arguments, one of which is a collection from A to B, a collection of A's. So I'll do square bracket, and a function from A to B as a type, and it'll return me a B collection. Sorry, B. Okay, so map's actually polymorphic here, and we'll take an A question mark and a function from A question mark and return me whatever B is. So the polymorphism there says that map knows something about the nilability of the collection and of the function arguments. He can track that through. That's not the normal thing you get out of Hindley-Milner, but it's not a terribly hard extension.
But that would mean that you have to know the collection statically inside.
No, you have to know that you didn't shove a nil into the collection. Not that you know it statically. You know that dynamically, no nils got jammed into the collection. Somebody generated the collection. Did the collection ever get a nil jammed into it? So all that happened out of that was I failed the proper moving forward of the requirements of nilability. And Alan had a question for me about something. We were talking about nilability and maps or whatever, and I went through.
Sounds like an easy mistake to make, though, to change one line of code somewhere in your problem, in your program, and suddenly have a whole bunch of collections of string turn into collections of nullable string. And then a whole bunch of functions now need to be recompiled because they all need to deal with the nulls.
Well, no, it's not that they do a type error on you. That's a different thing. I have a program that's running. I change the program. I expect to recompile the program. It's retyped. It's a whole new program. If I have a collection, which this is not a dynamic question. This is a static question. Yes, statically will a nil get put in? It could be that at runtime no nil ever comes in, but I can't tell that. Statically, no nil comes in to the collection.
My concern is somebody changes a line of code.
Yeah.
And that line of code sticks a null into a particular collection.
So I retype the program because you changed it, so it gets retyped.
Retype the program, and somewhere far away in the code base from the line of code you just changed, you get an error.
Yeah.
You can't do dot length on this thing because it's a nullable string, not a string. And you're like, where in my program did I do what that convinced Henry Milner that this thing is actually nullable string?
I mean, you get type errors always propagate far. I mean, if I go into some random Java program and I change some field to private, I get errors not at the private, but far removed, where you're just trying to use a private field here. And,
I guess the answer for that's not so bad, because I'm going to get that totally obscure error, and I'm going to go to my collection and say, this is not a collection of nullable string. This is a collection of string. And once I add that assertion in and rerun the build, now it's going to blow up where I tried to stick the null in, because the assertion is going to propagate backward just as much as the null was propagating forward.
Exactly.
If you deserialize collection from network from some binary representation, you have to be forced, in order to turn a collection into a non-nullable strings, forced to check each element.
Yeah, so if your deserializer is producing a nillable collection, he's a nillable collection, he'll take nulls. If your deserializer is producing a not nil collection, he should claim, I've been given an erroneous collection of data, it has a nil, and that's not allowed here. Same as a JSON deserializer. If it's malformed, you get a malformed error somewhere along the way.
Yeah, but strings can be null by default in Java, let's say.
Yeah, in a lot of languages, it can be null in places. So maybe you don't want to have a collection that's not nullable of strings. I go back and forth whether my collections have nills in them or not, according to the context of what's going on. Sometimes I have a hole in the collection at a point, and the null can be a space filler to make it fill out the collection there. Some of the collections I know for a fact that's never null, and I want it to be never null, and so I want the type checker to catch me if I accidentally put a null in. And I think that's a totally fair thing.
And sometimes I want an array of structs where certain elements in the struct are nullable and are not nullable.
Yeah. So all I'm saying here is that the implementation failed when I didn't track the right data. And Aaron, you're asking, where did that come from? And it turned out that I had been doing the forwards direction only. I have to do the reverse direction because Hidden Miller is bidirectional, and I didn't get a bidirectional case until I wrote the last line and the first code block. That was my place where I first saw the function pointer arrow pointer field gets a type from inside of it that says pointer cannot be null. The application of function to an argument is outside, and it just takes the argument and tries to shape it to the insides, and I had failed to propagate it backwards out. So
I assume that null has no fields on it.
That's correct.
Because you'd been using 0 for null.
Yeah.
And I was thinking, oh, are you going to get into a weird point where you're like, does null have a null dot to float?
It does. So I'm lying when I say it has no fields. It will. I haven't done this yet, but I'm probably going to. I will use the same argument as integers do, but it'll be a collection of functions where mostly these will be operators, where the left-hand side is a null and the right-hand side is whatever you did. So if you do 0 plus 5, I'll look up plus on the 0, which I could look up plus on the integer version of 0 and get the correct answer as well, that they're identical functions. I don't know if that makes.
I kind of want null plus 5 to be an error, not.
Why? Well, if I type 0 plus 5, what do you expect out of that?
0 plus 5, I expect to be 5. Null plus 5 feels like it shouldn't be 5.
Okay, I don't have, I on purpose have no distinction here. This will do, this 0 is semantically and syntactically the same for everybody. That's part of my weirdness budget, which isn't very weird. It's like what you get out of the old school C version of null. It can just go everywhere and it fits fine. Like it doesn't have any semantically errors. You're adding a new state to null, meaning it's not a thing, and that's not what it is.
So if I have anything that is nullable, but the things that I'm calling on it also exist on integer, I may not notice that I've had nulls go by.
Well, if you do ABC plus 5, you're going to get an error, right? If I do P is equal to random question mark ABC :0, P will be typed as a nullable string. And then if I say P plus 5, you'll get an error.
But if I have a bunch of objects that I'm two-stringing in a loop, and suddenly I get a null, I'm going to see a string 0.
The objects you're two-stringing are, you'll get, well, I'll probably have two-string on a null work. That would just be the obvious conversion.
And give you a null or give you a 0?
It would give you a 0 string. Well, that's a good question. We'll have to sort on that one, because I know I want to do this. So if you do ABC plus DEF, oops, that's, string concatenation. But this also works fine for null. Let me do that, and then, ABC quote plus 0 equal ABC. That's obvious. Well, 0 plus 0 is equal to 0. That works for strings and ints both. It's ambiguously identical.
And I assume if ABC plus DEF is the longer string, are you going to do ABC times 3 is ABC, ABC, ABC?
I don't know. The times one on strings is sort of less important to have functional. Now, if I do it, I'll have to make sure it is completely ambiguously identical whether 0 is there or not. Like there will be semantically no change. And I can probably do that with the obvious 0. 0 times 3 is 0 for both stringy thingies and not stringy thingies. That's fine as well. But I don't care terribly to have a semantics for times on strings because it's such a rare operation.
Mostly I just use it because I'm multiplying it by true or false based on whether I want that string or not.
I'm sorry, two people talked at once here. Aaron, why don't you go first?
Most of the time I've used multiply on a string. I am multiplying it by either true or false based on whether I want it to show up in the concatenated string or not.
Oh, that's interesting.
So I sometimes have, string plus string times bool plus string.
Because you're trying to filter on a bool in the string.
Yeah.
Okay, fine. That should work here. That'll work the same way.
That's interesting. I've seen a lot of multiplying strings in Ruby, but I don't think I ever saw a string multiplied by a Boolean, which seems more useful.
I
But
get it.
I think this is a vague memory because it's one that I never used, but I think that they also had like string divide, which was like split.
Oh gosh. Okay.
Yeah, I'm
You
not
can
sure
kind
about
of go
that
down a
syntax.
kind of silly rabbit hole with this stuff.
What does it mean to divide a string by 3?
Well, it's split at the character 3, I guess, or.
Oh, geez. No, I'm not doing that. That would be an argument for division as on a string, which would be, you know. Oh, why don't we put a slash in here? Hang on. Maybe. You know. There's a divide operator. I don't necessarily think that's sensible or want that as a default or anything.
But
Yeah,
as a math operation, you can infer what it means.
You can squint and make it do something sensible.
Yeah. Why not?
Except that multiply and divide are no longer reciprocal at that point.
Yeah, yes, good point as well. No, I don't want to go there. Fine.
Well, yeah. Well,
I'll let you define your own user operators to shoot yourself in your own foot.
Yeah, I guess it depends if you decide to make a collection times a string to be a join.
Oh God.
Of course, it's ambiguous. Yeah. What do you want to do with the character you're or the string you're dividing? Or does it mean a split? To remove the commas in the splitted string? Does it mean retain the commas in the splitted string? It's
split usually doesn't keep the splitted character, but yeah, you're right.
Yeah.
So one of the things you can think about with nil is that it's polymorphically shape changing to match what it's around, but in a sort of mathematically safe way.
So what's the type of nil?
Exactly. It doesn't have a type that you would recognize in the sort of the usual Scala, Java, C types. It's a member of a lattice. Yeah, someone's trying to make these the inverse operations. I don't know that would. And it lands in the middle and then can shape change to people around it sort of freely. So if it's used in a context of an int, it will behave like an int. And if it's used in a context of a string or a pointer, it behaves like a pointer. And operations that can produce it via, say, identity functions like adds of 0 and something, or behaves like an identity function, it will behave like an identity function. So 0 plus string is that string. That's an identity function for it.
Will a nil have a place in
so
lattice if it's a type?
Nil... Sorry, go ahead.
No problem. Will a nil have a place inside the lattice as its own type? So
it has a point in the lattice.
Yes. It has a point, but the point have to be, I'm assuming it has to closer to nothing.
It's in the center, but it's not necessarily related to pointers to classes and classes with subclasses or whatever. So it floats in and around or interacts with pointers and function pointers and data pointers and ints and floats.
But most of the things can be nilable, as we've shown.
Right.
So the nil have to be their common ancestor or common.
Many things funnel through to nil in the lattice. Yes.
So what's above nil? If many things can be nil.
There's a center line and it's symmetric. So everything that's below the center line has its dual equivalent above the center line. Pointer to ABC has a below center line, has an above center line version, which is a choice of string-like things that look like ABC strings with whatever other properties are going to be choices there. Nil lands in the middle. This is a picture of 1,000 words I don't have other than a hand scribble.
Yeah, we've been over. I remember we've been over to this, but in this concept, I believe the nil if it's in the center, that means the nil is a value inside this type. Let's say if it's a int, if it's an int or negation int. Yeah, that was the inversion of int. Yeah.
Yeah.
That the one means all ints. The bottom means all ints in no in particular, or no choice between
One is
choice
all choices of integer values, including the zero choice.
Yeah,
One is all integer values. I don't know what they are. Could be a zero.
Yeah.
Right.
I mixed them. Yeah.
Okay.
Great.
That's right.
Nil becomes in the center. That would means that nil is a value somewhere in between, or no value in particular.
If you meet nil with another value, you get a sensible member of the lattice. That's the nil with nil version. All the ints you're talking about have nil in them already. So meeting them with nil didn't change anything. So in that context, meeting an int with a nil is very much like meeting an int with a zero. And they just become the int that you had before, or the join of the int, or whatever. The negative and the positive versions all do the obvious thing with zero. There's a non-nil, not a zero ints, nint, not zero int. And all my types have a not zero property. It is symmetrically uniform throughout them all. I have the nil and the not nil version of everybody. So therefore, that's what makes the lattice symmetric. And that's why I can add nil in to anybody or not have it anybody and have it be this polymorphic flavors, because there's always a version that doesn't have a nil and a version that does. And I can always pick which one I want to talk about.
Can your nints be negative?
Yeah.
So I could have a type that was -7 to 7, but not 0.
Yeah. Yeah. Nints are signed. Yes. So an int 8 is 8 bits of integers excluding 0. It's an odd piece. You probably don't care for that type, but it's necessary to make the lattice symmetric. So it appears. I have a lot of types like that are necessary.
And it has 255 possible values.
Yes.
It's not like it goes from -127 to +127.
No, it's a standard sign 2's complement integers.
Okay.
-128 to +127, excluding 0. And so bool is really an int 1, and there's the nint version of int 1 is oddly just the number 1. It's the constant 1.
I was just about to ask about that one.
Yeah. So I think it works how you'd expect.
Every type has its own nil version.
Yeah. So pointers have a nilable, not nilable, every possible pointer.
Yeah.
This is all like on the primitives, really.
So very slight sidetrack just on that. Do you think there's any serious disadvantage to having -1, the true value being -1 rather than being 1? Or
I think there is a disadvantage to having a forced particular value for the truth that is not 0, but is also not just any not 0 value. After you pass that hump, it doesn't matter anymore.
Yeah.
So I
see a lot of C code that tends to multiply by true, and we're actually just talking about multiplying string by true.
Yeah.
Because in C it's weak. Everything has to be converted to integer. Can be converted to integer.
Well, I don't know what it means to multiply a string in C, because there ain't no strings in C. There's only pointers.
No, multiply by true and false. No,
true and false in C are macros for 0 and 1.
So
I
would agree that a signed Boolean true is -1.
Yeah, the deal I don't like is when Java, I want to check somebody for null. I have to do a specific check for null to get a Boolean out of it. And, that's just too common an idiom for me to have it not have a shortcut that just says I can check a pointer for null by just doing if pointer.
But that would work fine with -1 for true.
It would, but the deal is if I have to force generate a -1, if I wanted to convert something to a Boolean, and I had to force it to be a particular value other than 0, I have to emit code to force.
Well, we know it's J and Z that you're going to
Exactly. If you don't have to emit code, then I can just do a fucking J and Z. Cameron's right, and he's trying to be snarky at me, but he's totally right. And that's
being snarky.
Yes, sir.
So
someday
No,
I'm going to get a hold of your cast. I'm going to write something snarky on it as revenge. The blank slate. I can go to town on it. Oh, there it goes. Yeah, what to say? Don't blink. Oh, don't break.
Break in case of emergency. Break in case of emergency.
Break in case of emergency. Oh, geez. Yeah, we already had the emergency fine. No. What the hell were we doing here? Yeah, so if you need to have the JIT force to a -1 or a 1, you're emitting code for doing that.
So Cliff, I totally agree with your.
I totally agree with you. Clean that out, but semantically, you're forcing a -1 when you didn't need to.
Yeah,
I totally agree with your code production. I just hate the syntax implication.
What, the if pointer, then else?
Yeah, I mean,
if.
I know why you do it.
Yeah, I like the falsy null. That's
if
just
pointer, then else. That's my, except that's got keywords on it. So I'm actually for AA, of course, it's pointer
I've
question
kind of
mark.
kind of fallen in love with types actually doing what they say.
Okay. What does nil say for you? See, nil says something different for me.
I don't have a nil, I have a null. But yeah, I mean, null is just a sentinel value as far as I'm concerned.
Yeah. I have made it a sentinel in one case and a valid member of the integer or float syntax in the other case, and have also gotten to the point where those are mathematically ambiguous. So it can be used in any context without.
The challenge is that you're false, you're 0, you're 0.0, or at least most of them, and your nil are all the same value.
Yeah, I think the problem you're thinking here is value. 0.0 is actually a floating 0. It is not. I will allow it to be tested for false, but if you said 0.0, you got a float. If you just throw 0 down, it's ambiguously an int. I'll have to look. Well, let me think about that one.
So
I know it's in the
lattice
lattice there.
that you also want the empty collections to be falsy?
No.
The empty list, the empty dictionary.
No, those are not falsy.
Does it mean that if I create if I create a structure or something, I set a value to 0, I could actually stick anything into that place accidentally because the 0 doesn't really force it to be an integer?
Right, so I'm making my struct. My struct is a struct. I have a field X, which I didn't assign, and I carried on. Okay, that gives me a field which is currently untyped and set to read write nil. Later in life, I don't like my struct, it's too long. I'm gonna go back to pointer. I'll say pointer.x : equals 17. Or pointer.x : equals ABC. But I can't do both because I'm going to claim that because you're assigning a 17, it's an int field, or you're assigning a string, it's a string field.
How would you recognize the fact that can be nil in the ABC case, or in both? Actually?
Well, in both cases, it can be a nil because you didn't assign anything, so it got a nil, because you always get a nil if you don't say something originally. So immediately a nil is possible.
So X is always nil or something.
Because you didn't say anything. So if you came through here and said equals 17, you can't have a nil.
But if you say equals 0, it's not I guess it doesn't really affect the functionality because the functionality is really defined by what you actually do.
Yeah, so if you say equals 0, your final field of a 0 is probably what you meant. You : equals 0. So X by itself is a syntactic shortcut for X : equals 0.
Yeah, but I guess what I'm saying is that you lose the code sort of communication saying, I've initialized this into 0. You're really, or you can do it sort of on a conventional level and say, I just say X without the equals 0 for for, you know, if it's a nil, you know, conceptually, and x equals 0 if it's an int conceptually, but I'd have to like come up with that convention for myself.
Well, for me, the obvious thing here is you don't have any type information on x. It's being inferred. It's like in Scala or Java, you said var x.
Right. Yeah. So I'm not talking about the type system here now, really. I'm talking about like for the programmer looking at it and saying, what is x?
Well, you have a poorly defined structure with no annotations and no hints. So I claim that this is like, you know, code smell already. So replace pointer with point, and I say x, you know, y, z. Okay, I got some hints as to what the hell I'm talking about. Maybe I want to have this be pixel, and these all be ints. So I want to actually put a type annotation on them to make it more obvious, right? Oops, whatever. So I can write obfuscated code in any language. You can certainly obfuscate in AA.
Okay, well, you could have color, could be numeric, or it could be a string.
In fact, I can do an overload on you and do both. That's an overload. But yeah, fine. So here's color. I'm going to do color with the string, and I'm going to do color with the hex value. So here's color.
Yeah.
Right.
Right. So yeah.
And now I have C, which is typed as a color, which I claim as I'll do a color constructor here. Right. I don't need the annotation on C. It's generated by the constructor for color.
Yeah.
And, you know, I can.
Why'd you reach for a semicolon rather than a comma in that struct?
Oh, because inside structs, I use semicolons, so it's syntactically identical to top level just statements. And in fact, it's exactly statements. It is the same parser code, the same parser, the same syntax being executed by the same thing. So semicolons.
And Henry Milner is actually learning that name is a string because you passed in a string to the called color.
Yes.
And working backward.
Yes. Yes.
The type is determined after it's used.
Yeah. Here it's all determined by uses. That's correct. This is what type inference does, right?
So if I add another call to color where I got those backwards,
you get an error.
Yeah.
Here's a not error version, and then I'll do
I'd
green.
call this global type inference in that it's not
global type
localized.
inferencing.
Yeah. The
Because we
globals
do
are
type inference, but we don't do anything like this.
and if I want my name to be some kind of boxed type dynamic,
You put a box type dynamic in there.
it genuinely could be either a string or a number.
Or you have to put a box. So you can't mix numbers and strings alone. You have to box the number.
So the thing that I put a few lines lower, does that make sense?
You didn't tell me what box type is. No, because you don't have a box. There's no syntax shortcut here. You have to define a box and fill it with a tag union to say I have an int or a string or whatever. Yeah.
The first usage would determine.
Okay, so at the top I would just say box equals union int string.
Yes, and I don't have those built into the type system. So I can have a box that has no fields. I have an int box and a string box, and the int box has only a primitive int field, and the string box has only a primitive string field, but it's a box. So that's a pointer to a struct already. So you've already boxed it. And then color can have a box for name.
Right, but if box is just a struct, I have to say
you have to
pointer.x.int means or pointer.x.string means. I can't just say pointer.x means.
No, but if you want to go play overloads, you can get away with overloads for reading. Now, not for writing, but for reading, you can use overloads. But the overloads behave a little differently than what we're doing here. So I can go do the box example and show you a boxed thing that the box contains ints or strings. And that's separate from doing overloads things. So box is a type which has nothing. And then an int box is a type which starts from a box and extends X with an int field. And a stir box is a box which extends X with a stir field. Then pointer is got a box, an X field called box. There we go, box. Okay, and now I can put a box in for X where I say int box of 17 or stir box of ABC, right? Let me see if I syntactically got that correct. So yeah, I think so. I just made a I don't need to struct with X in it, but you know, I'm kind of adding around. But you can have a box and you can put things in it. But that just said you wrapped already.
And that's not going to give you an error when you set pointer.x.
I send it to one of int box or stir box. Yes, or any kind of box. Now, if I put a box in pointer and later I come along and I say pointer.x in an expression, but inside the boxes is another X, I don't know if I'm looking at an int or a string.
I guess the thing that confuses me is the fact that you wrapped them in the call to int box and stir box.
Well, I was boxing them.
Right, but what you're setting it to is pointer.x.
Which is typed as a box, which is the common subtype of the other guys. I missed my columns here. Because this is a type.
I'm getting confused because the X's inside the box are not the X's that are
call
inside
these
the
things
box.
differently.
Right.
I
X.
and S. Got be happier?
And if I want to access the int or string,
You better cast it to an int box or stir box, which means you need a runtime test, which means you need a type test. Or a virtual call that's going to pull them out. Yeah. Those are the fields. I can add a virtual call and you can make a virtual call to go pull the thing out. But it won't be typed. It'll be typed as a function that returns an int or a function that returns a string, which won't be which won't type you. That's actually I can't do a virtual call to pull them out. And
yeah, the virtual call would still have to return one of these boxy things.
Yeah, right. You can only say, I have a box. Let me ask what kind of box it is. From the kind of box I got, I can now pull out the int or the string. Now, having done that, I can do the same
But
thing.
if I later call toString on pointer.x, both int and the string have a toString on them. So is there a way to?
Okay, so the first cut here is that box doesn't have a toString on it. So I can add a toString on box.
I would end up with a toString on box.
Yeah. So I want to claim I have a toString on box, which I'm going to leave as an assigned hard nil. So that's a virtual call that you can't call because it's known to be a nil. And I can put a toString here, which is a function that takes no
returns
arguments.
i.toString.
And does i.toString, yes.
And the other one is going to be s.toString.
Well, yeah, except that's already redundant, but you can do it that way if you want. You just s.
Fine, I just returned s for that one.
Yeah, right. Fine.
And now I can say pointer.x
toString. Yes.
Okay.
Yeah.
Cliff, I got a question for you on the color example that you've got. So you've got a code base that already exists, and you got a lot of references like the first one where it's string followed by integer. And then you introduce one where they're transposed. Is it, the compiler can definitely detect the inconsistency, but how good is it at reporting an error to say this particular use is the one that's inconsistent, or does it fail at every use site?
So, that's a matter of what I can do about error messages. If you wanted to put type annotations on name and hex, then that's the obvious place I'll report. I'll report at the guy who's inconsistent with your type annotation. If you don't have any type annotations, then somebody randomly is the first person to notice the conflict. And then I'll end up coming around and probably reporting you at every conflict point, which I'll probably come back through. A better error message would be come back through and count them and say, I have 17 this way and 1 that way. I'm going to report the 1. But that's a quality of implementation of error messages.
Yeah, I mean that's the basis of the question, right?
Yeah,
Is that
yeah. Right
if
now,
the type inference can see the distinction, can it help you figure out what you need to do, and instead of erroring out on all of them?
Counting versions of left and right versus left. What'll happen now is I'll have said, I found blue and int, so I'll complain that I'm mixing blue and 789. Later along comes red, right? It turns out that right now, when I'm doing my typing, I will know that I have a red and a blue versus a 789. So I know I have a string versus an int, not a blue versus an int, but a string versus an int. But I won't be able to tell you that I had 2 strings and 1 int. Therefore, tag the int. And I do track where these points are. So I could tag one or the other, but I don't track the counting of how many I got. That's probably something I could do. The way I do errors right now is that they are part of the type. So there's one true type for every program. Like if you get past the parser, you don't have a syntax there. Get past the parser, your program will type. 100% guaranteed it will type. Now its type may contain error types, and then I won't be able to generate code for you. But it will have a type. That means I have only one canonically correct error for a given kind of analysis I do for the typing. Right now, the kind of analysis I do doesn't count the number of reds and blues versus 789s and 123s. So it will always pick them all and say all of them are in error. That's part of the error message. That's part of the type. That's the correct type for that program is the error message. You can't mix int and string, and I'm not going to tell you, except either going to tell you no place or going to tell you 3 places, which is not, either one's not a great answer. Okay, so there's another analysis that's stronger that says, in addition, I'm going to count the number of times I unify types that are distinctly different, but would otherwise unify. And then when it comes to an error, I'll report, the error will know I have 2 here. The correct type will be 2 strings and 1 int. And I can't mix ints and strings. That's the correct error. And then I might report on the 1. But the error message, in fact, could say, cannot mix int in 1 place and string in 2 places. I mean, I would have to have that information. Then I could report the one loser.
Yeah, I kind of like the idea of grouping those.
Oh yeah, totally.
So that it's like, hey, you can either change this 1 line or these 40 lines, up to you.
Yeah, right, exactly. Well, then also I would probably go back to the color name line and say, and you also might want to throw down type annotations here if you don't like the error message. You'll get a better error message if you actually wanted the 40 printed out, not the 1.
Yeah, and I might actually care about the 40.
Yeah, that's what I'm saying.
Because if I'm doing a refactor and it's like, yeah, I want to switch the order, I'm going to switch one of them, generate the error, and then go fix the other 40.
Yes. Oh, that's a volume thing on the printout. There's the short error message that says, here's an example of where you got it wrong. And then the long message that says, here's all 40 examples where you got it wrong. And when you do Java or C compiler, he blows up. Sometimes he runs on, he stops. Java just stops after the next 100 error messages. Time to glue out your IDE and do a bulk refactor and not screw around here.
You have opinions on letting the errors get big? I mean, I've heard of C++ compiles that have.
Oh, I get ludicrous. I've seen the ginormous ones out of C++. Yeah, no, I believe error messages should in general be concise and obvious and have enough hints to tell what the hell's going on. It's the obvious thing. But if they scroll on and on and on, then there's something you're not doing well about how you're reporting. And you minimum should hint to the user, if you make this change, I'll give you a tighter error message. So I get him out of Elm all the time where he spews at me, but he tries hard to say, I have this conflict in these points. And then the second little comment at the bottom is, if you threw some type annotations in, I could tighten the error message down.
Well, the other thing is, a lot of compilers, when they hit a bug in the code, will hit it over and over again from different perspectives. So the same error becomes 10,000 error messages. So what you want to do is pick out the original sin and show that.
Yeah.
So
I definitely have
but it's not there's no magic bullet, no silver
You need-
bullet to do it.
I
You need
definitely have a
compiler
reporting.
for your error messages.
I'm sorry, what, Dirk?
You need a compiler for your error messages.
Yes. Yes. Well, that's the point.
Or
I definitely have a
ChatGPT.
reporting strategy that says when I'm doing the type analysis and I reach an error point, the flow side at least switches to having an all type for the types of things, which is a poisonous, your mistake moving forward. Then when I go error reporting, I stop at the first place and all shows up and don't report all the subsequent fails. And so you get the error message at the first point that I notice something's going on there. And if there's a well-defined first, what there is in the flow side, and there's not on the Hindley-Milner side. All right, we're getting on, and I have an appointment that I shall not miss. So I want to wrap it up here.
Yeah, I think it will be helpful to actually get in real error messages to understand where they are good or bad.
Oh, absolutely. And I have some effort made. You know, a lot of my tests have the expected error message I want, but that doesn't say that they scale up to big programs or anything.
One last question: is this Lego AA? What I highlighted here?
I don't. It's my intent for that to be legal until somebody explains to me the error of my ways.
No, I would argue strongly against it, unless at this point you have to unify this type with this type. You have to have
the unification of int box and stir box is box.
And the box is nothing. The box doesn't.
That's correct. You have to cast.
Yeah. If you scroll a little down, we have
more...
even an even discussion about. But Scala would allow this, even though you can change later the type.
Because you have a different code here. You have box and not int box or stir box.
Here, the box is here with generic type parameter. Here is the inbox and here is the string box.
Okay, you have a different syntax for, I don't know the Scala syntax. So box of A puts an A type on the box. Yeah, I would claim that pointer.x has a Java style class hierarchy. You have the box. You could do polymorphic type variables for that, but then I'll complain that the A here, the type for your A is a mix of int and string, and I will also disallow that. These two programs are different fundamentally. The polymorphic type variable there is only going to work if you're going to use it in a context where the polymorphism lets you distinguish ints from strings in all contexts, which assigning it to a field like that does not, but passing it around function pointers does.
So that would be the semantics.
Yeah, the one above says, I have a generic box, he has a toString, and the subclasses have other fields. I don't know what they are. But everyone agrees that we have a toString. So I'll let you call toString. And then you get a free upcast for each of the two strings, and the int and the string box all do something. And if you pass in a raw box, you'll get an NPE there, or I'll probably type you and say you can't make a raw box because you're calling toString and it might be nil. So I won't let you make a raw box. The initial definition of box will become abstract by default because you made a function call against a nil. And I'll give you an error left or right, however you want to get your error. So the first set of things are different because the box is upcast in the toString. In the second case, the one you have for Scala, the change here is that A is polymorphic. And therefore, you have two X's, by the way. So the second embedded X should be changed to something else here. Oh, no, you don't. Yeah, what do you call?
X is a variable. You can change the X with a new box, which is a polymorphic type. And the point being is that when you fix the box at the first usage,
so here
you cannot change the type.
You've said box is a type with not an int type, a type with a refined int 17. Or box is a type of refined string ABC.
No problem. The compiler would infer that it's a box.
Yeah, and I would infer that as well.
No problem.
And I don't support the or types of mixing ints and strings. So in this particular context, I'll blow you up. There is another context where I would allow you to have a box with a polymorphic type that was a known refined string. Oh, hang on, this is Lisa telling me to go to my meeting. Hey. Yeah, we are. I'm winding it down. Thanks for the call. All right, bye. Yeah, that was the get done and get out of here.
That was my original question, because this is nonsensible to do it, because
right. I'm not, and I won't allow that either. I guess probably for the exact same reason.
Okay.
I'm trying to think of a good. I want a good example of where I would allow that, but it would just be a place where you passed a box along to a typed box to a function that took a box, and then polymorphically he wouldn't know he had a 17 or a string ABC internally, and then when you return back, you had your, but the code internally would have to handle ints and strings both.
Yeah, you either have to unify or have to track somehow.
Yeah, and I'm intending for primitive types, I will allow specialization, but in general, the rule is, yeah, they'd have to unify, and I would blow you up for you fail unification.
Because it's, I believe you have to disallow this in general, because.
Well, saying pointer at X, but if I suppose I just make a box, let me go see. I got a short timer here, so I'm gonna shortcut and screw around here. Suppose I just make a box and I pass it along to a map which expects a box and does something with the A value. So I take a box, but I can't do anything. Oh, I don't have any value for A. I only have a type. So I can't do anything with, there's no value to do anything.
No, maps would expect a value, not a type.
Yeah, this is a type. That's not a value. I have to make a value. Box, you have made an empty box. It has no fields. It's an empty struct. The type A means nothing here because there's no way to use it to get a value of type A.
In Scala would be nothing either if you just make a new box without specifying its type.
Well, even if I say box of 17, there's still no value 17. That's a type. That's not value.
Oh, but map wouldn't expect, you have to have a type level map compute function. A map expects a value of the given type.
Yeah, and there's no type 17 being presented here.
And this is type entirely. Unless you have a function map that can operate on types, so this is a different universe.
Yeah, different universe. That's correct. I don't. So it's a different universe. So I'm going to erase this example. There's no example here. So I think we're back around to, I'll just give you a unification error and be done.
That's the most sensible things.
Yep,
if you can unify, then unify it. If you cannot, then give up with an error.
But the map needs a concrete value. In box, the only concrete value in box is the empty struct, the bare pointer. Pointed to an empty thing, whatever.
That would equivalent to a new in box.
Yeah, it's a new of an empty. Yeah. Yep. All right. I'm gonna call it quits here because I got to run.
Okay. Nice meeting you guys.
Excellent. Another great discussion. I got a meeting elsewhere. Got to go.
Thank you.
All right. Yeah, to meet again. I don't think we're going to have Jan for next week. I'm going to poke him again, but he's been ambivalent, which probably means he's not actually going to show. So I don't think we'll have a guest next week, but I'll poke him. All right, to meet again.
Bye, guys.
Okay.